Okay, I wanted to show you an easier way to do problem 7. The solution I gave you that I posted on Google Classroom, or that the sub posted on Google Classroom, or that I left with the sub. I'm not really sure, but I know you have a solution for number 7. Anyways, this is the way you can do all these probability problems, and it's using two-way tables, and it's an easier way to solve these problems. So this problem says in 2010, about 69.6% of the full-time law enforcement workers were sworn officers, and of those, 88.2% were male. Females, however, make up 60.8% of civilian employees. Choose one law enforcement worker at random and find the following. And it tells you all these probabilities. Okay, so this may sound odd, but just to get rid of these percents and decimals, I'm going to say that I have 1,000 randomly selected law enforcement officers, right? Well, we know that 69.6% of them were full-time sworn officers. Okay, so right over here under the sworn officers column, doesn't tell us male or female, but 69.6% of 1,000 is 696, right? That would make the number of civilians 304. Okay, then it gives us some more information. It says 88.2% of those sworn officers were male. So right here, 88.2% of these sworn officers were male. Well, if you take 0.882 times 696, you get, well, that must have been 614 officers. That would leave me with 82 sworn officers being female, or 11%, something like that. Well, now I can fill out a lot of this table. Oh, it says females, however, make up 60.8% of civilian employees. So right up here, there's 304 civilian employees. So I'm going to take 0.608 and multiply it times that, and I get 185. That would mean that 119 are male civilian employees. And then I just go through and do my totals. Okay. And 733. So out of these 1,000 randomly selected law enforcement personnel throughout the country, and we're assuming we have a good sample and we've selected from the population so that we have no bias and all that stuff. This is how the numbers, come out with these percentages. Now I want to know the probability that she is a female sworn officer. Well, a female sworn officer was going to be 82 out of 1,000. And 82 out of 1,000, because I just go to the female sworn officers, comes out to what we got doing it the other way. Comes out to 0.082. Right? Now we did that the other way, right here, using the way the book shows. Says if 88.2% of sworn officers were male, then 11.8% were female. So the female probability of female and sworn officer is 0.118 times 0.696, which is 0.082. But having filled out this table, I can just see, yeah, it must be 0.082 because it's 82 out of 1,000. Okay. Next one says the probability that he is a male civilian employee. So the solution that's given in the book says if 69.6 are sworn officers, then 30.4% are civilian employees. Of the 34.0, 30.4% civilian employee, females make up 60.8%, which means that males make up 39.2%. And so you multiply the 0.304 times the 0.392 and you get 11.9%. So a male civilian employee, male and civilian employee is 11.9%. But if I go over here, yep, sure enough, I got 119 male civilian employees out of 1,000, and that also is 11.9%. And to me, this is a lot easier way to do it on the table, because all I had to do from the beginning was just fill in the information they gave me. This takes a lot more thinking, and you can do it this way. You can go through and find all these and think about it, but filling out the table is just the way to go. Okay, probability that male or a civilian employee. So that's the because of our they're not mutually exclusive, and we're going to use the rule that we gave for not mutually exclusive. We're going to say the probability of a male times the probability of a civilian employee minus the probability of a male and civilian employee. So let's, this should be a plus right there. That should be a plus. So I'm going to go ahead and do that because it says or. Okay. Save that. Okay. So 0.733 right up here, I have that number, right? The probability of a male is 733 out of 1,000, so that's 0.7. And let's see, the probability of being a civilian employee is 304 out of 1,000. The probability of a male and civilian employee, well, we got that one. That's 0.119. So we're going to add the first two and then subtract 0.119. So we have 0.918 or 91.8%. So that's a high probability, which you would expect because you're saying the probability of a male, which is 733 of them, or a civilian employee, which is this. Okay. Now together those add up to more than 1,000, but we have to subtract off the overlap, the civilian employees that are males. So once we do that, we get up around almost 92%, which makes perfect sense. So I hope that recording explains. When I get back to class tomorrow, sorry I'm not there today. We are headed to Bisbee, as you see this, to play a volleyball game, but I will we'll do a little activity that shows all the ways you can figure out probability and all the symbols involved. And I think you'll come to the conclusion that I did, which is you can't really forget all those other ways, but using two-way tables is definitely the easy way. Okay, so hopefully that helps. And the two problems that I'm assigning to you this evening, I'd like you to try to use the two-way tables to do them.